Hey, what's up, Algebra 2? It's Ryan. Today we're going to be working on factoring quadratics using GCF factoring, difference of squares, as well as normal factoring when our a value is 1, as well as when our a value is greater than 1. You're going to be expected to be able to factor quadratics pretty quickly and efficiently, so it's important that we get a lot of reps at this, and that's what this worksheet is designed to do. Okay, so let's hop into this. First, we have GCF factoring. That stands for greatest common factor. So whenever you look at an equation that you need to solve, first thing you should do is see if there's anything you can factor out of all terms. So for example, in our first equation, 24x squared minus 8x, are there any common factors in this term 24x squared and negative 8x? Well, I know that 24 and 8 share a couple factors, and the greatest one of those factors is 8. So I'm going to factor out an 8 out of this. 8. And when I divide 24x squared by 8, we get 3x squared. When I divide negative 8x by 8, we just get minus x. Now on top of that, we can go even further. We have x's in each of these terms, so I'm going to factor out an x out of this. So we still have that 8 outside, but I'm going to factor out another x. And that gives us 3x minus 1. Now from here, we have 8x times 3x minus 1 equals 0. So we want, since we're multiplying these two, we want either this parentheses to equal 0, so that no matter what this value is, 8x, multiplied by 0, we're going to get 0, or vice versa. So we basically set up 8x equals 0, which we divide by 8 on both sides, and we find that x equals 0, so that's going to be one of our solutions. We plug in 0 for x, we have 0 times negative 1, which is just 0. We also want to set this parentheses equal to 0, so we do 3x minus 1 equals 0. And we move that 1 to the other side, 3x equals 1, and we divide by 3 to get x equals 1/3. So that's going to be another solution. I'm going to write both of those down here. X equals 0 and x equals 1/3. Okay, now let's move down to do this one. So this one, we have 4x plus 10 equals 0. Well, what are the greatest common factors of 4x plus 10? Well, we know that 4 and 10 both have a common factor of 2. So I'm going to factor out a 2. That gives us 2x plus 5 equals 0. Now, technically, I don't need this 2 out front. I can divide both sides by 2, and we just get 0 over 2, which is just 0. So we just need to set 2x plus 5 equal to 0 and solve from there. So I'm going to move that 5 over and divide by 2. That gives us negative 5 halves, or 2.5. Negative 2.5. Great. Now, let's do this problem. First thing I'm going to do is I'm going to move this 18 over, so everything's on one side. So let's do that right now. And so our A, B, and C values are 6, -12, and -18. So when you look at this, when this comes up on a test, you won't know what strategy to use, whether it's difference of squares or using GCF factoring. So one important skill is to is being able to recognize how you should factor it. Okay, but one rule for basically anything for all of math is just try to make things simpler. If you make them simpler, there's a lower chance that you'll make a simple mistake, and it's overall better. So if we have a chance to simplify, to factor out something, then we should take it. So 6, -12, and -18, they all have a common factor of 6. So I'm going to factor out a 6. And that leaves us with x squared minus 2x minus 3. Okay? And so now we want to factor this x squared minus 2x minus 3. And if you remember factoring, remember we want two numbers that multiply to -3 and add to -2. So let's think of some factors of -3. Well, it's going to be 3 and 1, but one of those have to be negative, so it could be -3 and +1, or 3 and -1, but we have to add to -2. So that's our two factors that multiply to -3 and add to -2 are going to be -3 and +1. So I'm going to factor this. I'm going to put x and x here. And we said our two numbers are going to be -3 and +1. And from there, we can set each of these parentheses equal to 0. So we say x minus 3 equals 0. And we get x equals 3. We also have x plus 1 equals 0. And we move that 1 over and we get x equals -1. So those are going to be our two answers. Okay, great. Now let's move on to solving by difference of squares. So you'll notice that in difference of squares problems, we don't have a b term, right? We don't have something in the middle. We only have two terms. And one way you can recognize that it'll be a difference of squares problem is that we're going to have squares, like certain numbers you should be on the lookout for, like 9, 36, 16, 144. You should try to definitely be familiar with your squares so that when you see something where we have, where's a good example? Where we have 9x squared minus 81, 9 is a perfect square. X squared obviously is a square, and 81 is a square. So and we don't have a b term, so it's likely going to be a difference of squares problem. Now I'm going to solve this one, and then I'm going to show you, I'm going to work backwards, okay? So difference of squares problem, we don't have a b term. That's because the b terms cancel out. So we're always, in difference of squares problems, going to have something where we add two values and then we subtract those same two values. So whatever is here is going to be here, and whatever is here is going to be here. And the way we figure out, what's above or on that blue and green line is we just take the square root. So what's the square root of x squared? That's just going to be x. So I'm going to put x here. And what's the square root of 25? It's going to be 5. and this is equal to 0. And from here, we can set x plus 5 equal to 0, x minus 5 equal to 0. I'm not going to write all that out. We end up finding that x equals negative 5 and x equals 5, respectively. So that's how we solve that. Now, I'm going to FOIL this out, so go from our factored form to our standard form to show you why this works. So, oops, sorry, that was bad. So we have x plus 5, yep, and x minus 5. Well, first we want to multiply these x's. So right, remember when we FOIL, we want to go from each part to the other part in the other parentheses. So we do x times x, we get x squared. And then we do 5 times x, we get plus 5x. We do negative 5 times x, we get minus 5x. And then we do 5 times negative 5, and we get negative 25. And you'll notice that our middle term, our b term, it ends up canceling out. And so we just get x squared minus 25. And that's basically why it works. That's going backwards. It's just proving, it's double checking that what we did is correct. And that's always a good thing to double check. I definitely recommend you take as much time as possible and double check on every single test. I'm a big proponent of double, triple, and in some cases, if you have the time, quadruple checking. One thing I should also say is difference of squares. It will only work if we have this negative sign in the middle. If it's positive, it's going to be imaginary, so we can't do that. Okay, let's do, so in this case, well, actually, let's do this bottom one right now. Here, let's think about why we can't. This isn't like a normal difference of squares problem where we have x, like for example, x plus 5 and x minus 5. By the way, we would call the relationship between these two parentheses conjugates, because it's our first, or we have sort of the same terms, but it's a plus in the middle and the other one's a minus in the middle. So x minus 5 is a conjugate of x plus 5. But anyways, we need this to be a negative sign because when we end up multiplying this out, right, we had a plus 5x and a minus 5x. We can't do that here, right? If it's just plus, we either need, x minus 3 and x minus 3, because we have negative 3 times negative 3 will give us positive 9, or positive 3 times positive 3. And if we do both of those, I'm going to write this out. If we do x plus 3 times x plus 3, for example, we'll get x squared, and then we'll have plus 3x plus 3x. And that doesn't cancel out. If it's a negative, sorry, let me bring this down. If we have, by the way, that isn't negative, or equals 9, that's plus 9. But if this is a negative, then we have negatives out here instead, and that still doesn't cancel out. Another way we can just see this, we have x squared. If we move the negative sign over, or we move this 9 over, we'll have negative 9. We can never multiply two numbers and get, we can never multiply the same number and get a negative number. That's impossible, because we have because a negative times a negative equals a positive, and a positive times a positive equals a positive. So this won't work. If we take the square root of both sides, we can get an imaginary answer, which we'll talk a little bit more later on this year. But the square root of x squared is x. And I'm going to separate this into the square root of -1 times the square root of 9. Well, what's the square root of 9? That's going to be 3. And you don't know this yet, but the square root of -1 is I. If you don't know exactly what happened there, that's fine. We'll talk about that later. But the answer to this problem is going to be 3i. Or technically it can be -3i too, I believe. Okay, great. Let's do one more traditional difference of squares problem. Let's do this one. Okay, so here what I do is we have our plus, we have our minus, or something like that. I take the square root of 9x squared. Remember, we have to take the square root of each component. So what's the square root of 9? 3. What's the square root of x squared? X. So we have 3x here. And we take the square root of 81. That's going to be 9 and 9. So we set both of those equal to 0. And we get, well, maybe I should write this out in this case, just so I can show you. Okay, so 3x plus 9 equals 0. We move the 9 over, divide by 3, we get x equals -3. We do 3x minus 9 equals 0. Move the 9 over, divide by 3, we get +3. So we have, not a parentheses. We have x equals 3 and x equals -3. Okay, great, perfect. Now let's move on to factoring. So, you know what? Let's start with this problem. Let's start with this problem. First thing I do here is move that 15 over. So I'm going to say x squared plus 2x minus 15 equals 0. So remember, we did this in our first sort of set. We want to find two numbers that multiply to -15 and add to +2. So let's just first think about some factors of 15. Well, we have 1 and 15, we have 5 and 3, and that's it. Remember that this is -15, so one of those numbers has to be negative. It can be, -1 and 15, or -5 and 3. But is there some way we can add 15 and 1 or subtract the 2 to get 2? No, we can't. So it's likely going to be 5 and 3, which are 2 units apart anyways. But we have to choose which one's positive and which one's negative. And it ends up being that we want a +5, right? Because if we do +5 minus 3, that gives us +2. And we do +5 times -3, we get -15. So we have this, right? I'm just going to put in our +5 and our -3. That equals 0. And you can solve, set each parentheses equal to 0, and we get x equals -5 and x equals 3. Okay, great. Now let's do something a little more complicated. And it gets a little more complicated when we have an a value greater than 1, as in this case. So remember, our a value is our coefficient of our x squared term. So actually, first thing I do if I see that our a value is greater than 1 is I'd see if we can factor something out. For example, let's see, we did something here. In this case, our a value was greater than 1, but we could factor out a 6, and then we get a quadratic that's relatively easy to solve because our a value is 1. Here, can we factor anything out? No, we can't. So how I solve this, and there's a number of ways to solve it. I take my a value, which is 3, and my c value, which is -25, and I multiply them. So 3 times -25 is going to be -75. Now, I want two numbers that multiply to -75 and add to +10. So this is reminiscent of what we were doing down here, right? And so you may have 1 and 75, but we're not going to add to 10 using that. We have 25 and 3, we can't add to 10. We also have 5 and 15. Yeah, sorry, 5 and 15. Sorry for a second, I thought it was tripping. Okay, 5 and 15. And since we need to multiply it to -25 or -75, one of those has to be negative. Well, which one should be negative? Since we want it to add to +10, we should have a +15 and a -5, because +15 times -5 is still going to give us -75, and +15 minus 5 is 10. Okay, so here I'm just going to rewrite this quadratic as 3x squared plus 15x minus 5x minus 25 equals 0. Okay, so this is still equal to our equation before. I just separated our b term into 15x minus 5x. Okay, and from here, what I want you to do is I want you to look at our first two terms. Just separate this. What's the most that we can factor out of these two terms? Well, the greatest common factor is going to be 3x. So I'm going to have 3x, and then we're going to have x plus 5 once we factored that out. And here, the most we can factor out of these two terms is going to be 5. So we're going to have x plus, or sorry, if we factor out a -5 out of both, sorry if this makes sense, if we factor out, yeah, you know what, maybe I'm just gonna, this might end up going badly, but I'm gonna say plus -5 and put a parentheses there. If we factor out a -5 out of both of these terms, we end up getting x plus 5. That equals 0. Now notice that we have, once we factor those two out, we have the same term in our parentheses. So from here, what we want to do is we want to take these two terms of what we factored out and put them together. So our factored form of this equation will be 3x minus 5, and I got that from here and here, and x plus 5. And from there, right, we set those equal to 0. I'm sorry, my bad. 3x minus 5 equals 0. We move that 5 over. We get x equals 5/3. So that's one answer. And the other answer, we move x plus 5 equals 0. We know x is just going to be -5. Great. Okay, let's do one more practice problem where we have our a value is greater than 1. Let's do this problem. Okay, I'm going to move that 40x over. Okay, and that's going to be -40x minus 12 equals 0. So we want to multiply our a and c values. So 7 times 12, that's going to give us -84. And now what are some factors of -84? We have 1 and 84. We also have 42 and 2. And those two values seem like in some way they can add to 40. So let's use that, 40 and 42. Notice that we have a negative sign out front of our 84. So we need one of those two values to be negative, and we also need it to add to -40. So those two values are going to be -42 and +2. Right. This is also where the more math you do, the more comfortable you'll just get with numbers and seeing patterns. So you'll, as you do this more, you'll be more comfortable with finding factors and finding which specific factors you need that multiply to your c value, or multiply to your a times c value and add to your b value. Okay, from here we're going to separate this. So here the most we can factor out is a 7x. So once we do that, we get x minus 6. The most we can factor out here is a 2. So we get x minus 6. We see again that we have the same term in our parentheses. We combine this 7x and 2 that we just factored out. So our factored form is 7x plus 2, and then x minus 6 equals 0. So, I'm not going to write all this out, but we move this to, we set 7x plus 2 equal to 0. We're going to move that 2 over and divide by 7. We get 2/7. In here, we set that equal to 0. We move that 6 over, and we get +6. Okay, great. Hopefully you found this lecture informative. We went over a variety of different ways we can factor quadratics. Again, here, this sheet gives you, you should solve by factoring, or you should solve by difference of squares. But one really important skill is knowing which method to use. And so we'll be working on that in the coming weeks. And you should definitely try to identify certain trends that occur when you're solving, or when the equation is in a certain way. That means we should use this strategy, something like that. But yeah, if you have any questions, definitely go to your teacher, go to Mr. Whitaker. Feel free to use me as a resource. That's why I'm here. Go to the tutoring center, and also just use the internet. There's a vast amount of resources online, so use them. Okay, great. See you later.